Hey, what's going on, guys? In this video we are going to see how to solve a homogeneous differential equation. First of all, we have to check whether this is a homogeneous differential equation. To check that one, what we do is we look at the powers and see whether it is equal. And if you look at this one, we have y cube right here, so power is 3. So everything should be power of 3, otherwise it's not a homogeneous. And here if you notice, y square, that is 2, and x, that's 1. So 2 plus 1, that's 3. Here 1 plus 2, 3, 1 plus 2, 3. So this is a homogeneous differential equation. Now after we found out this one, what we have to do is we have to make everything in terms of y over x. To do that, we take the highest power. Here we have cube, 3 is the highest power, right? So we take that one, and what we do to convert this one into y over x pattern, we multiply by 1 over x cube, right? It depends on the power. Since we have highest power 3, that's why we put 1 over x cube. If it's 4, 1 over x power 4, something like that, right? And if we multiply top by 1 over x cube, we have to do the same thing for the bottom. And if you multiply, you will get this one. This is going to be y cube over x cube. We can write that down as y over x whole cube, right? And then plus y square x, and if you divide this one by x cube, that's going to give us y square over x square. We can write that one as y over x whole square, plus, and same thing goes to this one. This is going to be y over x, and this also going to be y over x, and that's it. After we convert this one into y over x pattern, then what we have to do is we have to substitute this y over x to v, like v is equal to y over x, and after that we have to write everything in terms of v. And if we write this one, this is going to be v cube plus v square plus v over v. Now after we convert this one into v, we have to do the same thing, like we have to convert this y right here into v. To do that, what we do is, this is v is equal to y over x, right? So y is going to be equal to vx, and therefore dy over dx is going to be equal to, we differentiate, we plug this value in terms of y, so this is going to be dvx over dx. And if you do the differentiation, this is going to give us 1v plus x dv by dx. Now this is what we are going to plug instead of this one. After that, all you have to do is separate. It's going to be a separable, then we separate and integrate. Now let's go ahead and do that. So let's note this one down right here. And so we found out dy dx is this. So 1 actually v plus x dv over dx is equal to v cube plus v square plus v over v. Now let's see how we can separate this one. So we have to do something about this, right? Now here we have this v, and let's see. Okay, first what we can do is we can cancel this v. If we take the v common right here, v plus x dv over dx, and if we take v common on top, this is going to be v square plus v plus 1, right? In the bottom we have v, and this cancels each other, and that's gonna left us with v plus x dv over dx is equal to v square plus v plus 1. And if you notice, in this side we have v, here also v. So if you bring one of this v this side, that's going to cancel each other, so we can cancel these two. Now we can go ahead and separate and integrate. Now we want all the v terms in one side and all the x terms to the other side. Now since dv in the numerator, we bring the v to this side, so this is going to be dv over v square plus 1, and in the other side we are going to have 1 over x dx. Now after we separate, we integrate this one, and this is basically tan inverse of v, right? So this is going to be tan inverse of v, and this is going to be ln absolute value of x plus constant, right? Then what we do is, now we have almost done. Now our original values were in terms of y and x, but we changed it into v. Now what we had to do is we had to do the back substitution, like we had to bring this y over x back because the final answer should be in terms of y. So to do that, what we do is, we know that initially we took v is equal to y over x. We plug that one back right here. So this is going to be tan inverse y over x is equal to ln of x plus constant. Now here we need this one in terms of y, right? So to get rid of this tan, what we can do is we can take tan both sides. So if you take tan inverse y over x, this tan inverse cancel each other, and in the other side we are going to have tan ln of x plus constant, and this is going to leave us with this one cancels. Let's continue this one right here, right, since we don't have enough space. So let's say y over x is going to be equal to tan of ln of x plus constant. Tan of ln of x plus constant. Therefore y is going to be equal to x tan ln of x plus constant. So x tan ln of x plus constant, and that's going to be the general solution for this differential equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.